Okay, so before starting the sum, I will just say a few things. Suppose this is your window and this is your viewport. Okay, so this side is, this is X and this is Y, right? So how will you name it? So X will stand for the position of the vertical boundary. This is the concept of X, and Y will stand for the position of the horizontal boundary. And H stands for the position of the height, high boundary and low boundary. So few concepts are there, not concepts, naming convention. X stands for vertical boundary. Y stands for horizontal boundary. H stands for high boundary. And L stands for low boundary. Okay, fine. Now, among this, then what will be the naming convention? This point will be W for window, XL, and WYL. This will be WXH and WYH. Sorry, WYL. Okay. So this is the naming conventions which I wanted to elaborate. Now, if you do not remember this, still it is not a problem, because when sums will come, we will study the sums now. When sums will come, then all the coordinates will be provided to you. But since I as a teacher need to tell you about the basic concepts, so I wrote this thing. Okay. So first we will solve the sum from the concepts which we have studied yesterday. So first I will write the sum, okay, and then I will start explaining. Okay, so this is the sum which is provided to you. They have given you the object size, that is the rectangle. They have given you the window coordinates also, and they have given you the viewport location coordinates also, and you are asked that calculate the viewing transformation matrix. That means the matrix concept which we studied yesterday, product of translation, scaling and translation, right? Now, first we need to first draw the basic thing. So, okay. My A coordinates is 1, 1, then 4, 1, then 4, 4, then 1, 4. Okay. So let us think this is my A, B, C, and D. My window coordinates are 2, 2, 5, 2, 5, 5, 2, 5. Fine. So this is my so this is your window, and inside your window, this portion of the object has fallen, right? Now, first, if you remember yesterday's class, first the basic translation we did what? Anyone? Given any object, provided any window to us, what was the first step we did? We brought
translate
this corner of window to where?
to origin.
Anyone? We brought this corner of window to where? Translated it to where? The first step of yesterday.
Origin, ma'am. Origin, ma'am.
You need to see the screenshots or where you have written. You need to tell me. Then I will do the sum. What was the first step of the window to viewport transformation? What was the first step?
Translate to X coordinate.
What happened? Say, what was the first step of which we studied yesterday? Window to viewport transformation. What was the first step? It was a 3-step procedure. What was the first step?
Ma'am, translate.
Can you guys hear my voice? Is my voice audible to you?
Yes, ma'am.
Okay. So, what is the first step which we studied yesterday? Window to viewport, 3-step procedure we studied. What was the first step?
Translate.
Right.
Translate.
Fine. So, this translation, what do we do from the picture? What was visible? What did we do? What did we do? ऐसा एक सपोज ऑब्जेक्ट था और सपोज ये मेरा एक ऐसा विंडो था, हम इसको ट्रांसलेट करके यहाँ पे लाए और ये वाला पे हो रहा। सो व्हाट डिड वी डू? हम विंडो को कहां से कहां लाए? फ्रॉम द पिक्चर इफ यू सी, विंडो को हम कहां से कहां लाए? विंडो को लोअर लेफ्ट कॉर्नर ऑफ द विंडो।
to x
हाँ बोलो।
coordinate,
मैम एक्स एक्सिस पे।
हाँ मतलब लोअर लेफ्ट कॉर्नर ऑफ द विंडो हम ओरिजिन के साथ कोइंसाइड किए, ये और नो, है ना? सो वी विल शिफ्ट फर्स्ट, व्हाट वाज द फर्स्ट स्टेप? दैट शिफ्ट द लोअर लेफ्ट कॉर्नर ऑफ योर विंडो टू ओरिजिन। ठीक, अब लोअर लेफ्ट कॉर्नर का कोऑर्डिनेट क्या है? एनीवन?
2 2
2 2। अच्छा, अभी जब 2 2 का शिफ्ट करेंगे मतलब नीचे की तरफ ला रहे हैं, मतलब क्या होके बैठेगा? क्या सीखे थे?
2
minus
0।
2
-2 परफेक्ट। ये बन गया मेरा फर्स्ट मैट्रिक्स। सेकेंड, शिफ्टिंग के बाद हम लोग क्या कर रहे हैं? हम लोग क्या किए थे शिफ्टिंग के बाद? शिफ्टिंग के बाद हम लोग स्केलिंग किए थे, है ना? स्केल क्या करेंगे? वी विल स्केल आवर विंडो टू आवर व्यू पोर्ट। दैट मीन्स विंडो का एक डायमेंशन तुम्हारे पास ऑलरेडी है, तुम्हारे पास ये डायमेंशन है विंडो का, और तुम्हारे पास ये डायमेंशन है व्यू पोर्ट का। सो विंडो टू व्यू पोर्ट scaling I will do, but for scaling I need to find out the sx and sy values. So sx और sy वैल्यू करेंगे कैसे, है ना? sx मतलब क्या है? width of viewport by width of window, और sy मेरा क्या है? height of viewport by height of window। ठीक है, अब तुम्हारे पास जो ये कॉन्सेप्ट था, ये देख के तुम हमें बोलो तो width of viewport क्या होगा? विद क्या है? व्यू पोर्ट को तुम्हारा इतना 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 सब वैल्यूज दिया गया है, और हाइट, हाइट क्या है? ठीक है, ये वाला जो तुम्हारे पास लॉजिक है ना, हाइट का, लो का, ये लॉजिक यहाँ पे बैठाना है व्यू पोर्ट में। तो जब भी तुम बैठाओगे तुमको तो हाइट मिलेगा व्यू पोर्ट का, एक के बाद एक, है ना? सो वो तुम्हारा विद बनेगा, तुम्हारा पहला वाला क्या बनता है? x वाला विद बनता है, और y वाला क्या बनता है? हाइट बनता है ना? तो x वाला वैल्यूज अगर विद बनता है तो मेरा मैक्सिमम x वैल्यू कहाँ पे है? 0.51 1.51, और मिनिमम x वैल्यू क्या है? 0.55। तो यही तो हम बैठा है, मैक्सिमम x वैल्यू ऑफ योर व्यू पोर्ट एंड मिनिमम x वैल्यू ऑफ योर व्यू पोर्ट, उसका माइनस किए। सिमिलरली हाइट के लिए क्या करेंगे? मेरा y वैल्यू क्या है? 0 0 0.5 0.5, दैट मीन्स मैक्सिमम y वैल्यू ऑफ योर व्यू पोर्ट माइनस मिनिमम वाई वैल्यू ऑफ योर व्यू पोर्ट, यही तुम किए व्यू पोर्ट के लिए। सिमिलरली विंडो के लिए भी मैक्सिमम एक्स वैल्यू कौन सा है, 2552, यस और नो। तो फिर मैक्सिमम एक्स वैल्यू है 5 और मिनिमम एक्स वैल्यू है 2, है ना। तो सिमिलरली विंडो का भी मैक्सिमम एक्स वैल्यू है 5 मैक्स एक्स का, और मिनिमम वाई का वैल्यू था, मिनिमम एक्स का वैल्यू था मेरा 2। सिमिलरली फिर से देखो, मेरा फिर से विंडो के लिए वाई कोऑर्डिनेट्स में कौन कौन सा है, देखो 2 है, 2 है, 5 है, 5 है, मतलब फिर से मैक्सिमम वाई वैल्यू मेरा बिटवीन द वाई कोऑर्डिनेट्स 5 है और मिनिमम वाई वैल्यू मेरा है 2। तो इसलिए यहाँ पे भी मेरा 5 - 2 निकला है और यहाँ पे भी मेरा 5 - 2 निकला है। सो when the coordinates will be provided to you of the viewport and the window, among the coordinates using the concept of x, हर एक coordinate बैठते कैसे, it's a pair of x and y, so among the x values what is the maximum and what is the minimum, माइनस करोगे तो with मिलेगा। among the y values what is the maximum, what is the minimum, माइनस करोगे तो height मिलेगा। ये व्यू पोर्ट का हाइट और विड्थ निकला। सिमिलरली फॉर द विंडो व्हाट इज द मैक्सिमम एक्स एंड मैक्सिमम वाई, माइनस द मैक्सिमम एंड मिनिमम एक्स अमॉन्ग द एक्स वैल्यूज, विड्थ ऑफ विंडो मिलेगा, एंड माइनस द मैक्सिमम वाई वैल्यूज एंड मिनिमम वाई वैल्यूज, height of window milega. So whatever it is provided to you, accordingly you need to find out the value of sx and sy. So this will become 0.5/3. So suppose 0.16, this will also become 0.5/3, means 0.16. So once I have the sx 0.16 and sy 0.16, then I will put it here. Fine. This was my scaling matrix. I have first written the translation matrix, then I have written the scaling matrix. अब थर्ड स्टेप मेरा क्या था, कोई बताओ? What was my third step?
Translate.
Translate मतलब translate back. Translate back किसको करेंगे? व्यू पोर्ट को ट्रांसलेट बैक कर रहे हैं। पहले को हम क्या किए, पहले विंडो को ट्रांसलेट किए टू ओरिजिन, बट नाउ वी विल ट्रांसलेट व्यू पोर्ट बैक, वी विल ट्रांसलेट द व्यू पोर्ट टू इट्स डिजायर्ड लोकेशन ऑन द स्क्रीन। ठीक है, अच्छा, तो उसके लिए हम लोग क्या ट्रांसलेशन करेंगे, हम लोग कौन सा वाला, हम लोग विंडो के लिए अगर लोअर लेफ्ट कॉर्नर को लिए हैं तो व्यू पोर्ट के लिए भी हम लोग लोअर लेफ्ट कॉर्नर को लेंगे ना। सो व्यू पोर्ट का लोअर लेफ्ट कॉर्नर कौन सा है, बताओ कौन सा कोऑर्डिनेट है व्यू पोर्ट का लोअर लेफ्ट कॉर्नर?
मैम 0.50।
हाँ, व्यू पोर्ट का लोअर लेफ्ट कॉर्नर है 0.50। फाइन। सो ओके, सो व्यू पोर्ट का क्या करेंगे, वी विल ट्रांसलेट व्यू पोर्ट टू इट्स डिजायर्ड लोकेशन। और व्यू पोर्ट का हमने अभी सीखा कि कोलोअर कोऑर्डिनेट से 0.5 and 0। सो इजी, व्हाट विल बी द ट्रांसलेशन देन? बस, है ना। सो ये पहले हो गया ट्रांसलेशन का मैट्रिक्स, देन मेरा आ गया स्केलिंग का मैट्रिक्स, देन मेरा आ गया ट्रांसलेशन का अगेन मैट्रिक्स। So when I will multiply these three matrices, I will get a certain result. Now that result will be my window to viewport transformation matrix answer. This is the way how you solve. Okay. So your motto is, whenever a sum will be given to you, the window coordinates, the object coordinates, the viewport coordinates, everything will be provided to you. You need to first, using the lower left corner of the window, using this coordinate, you need to first prepare this matrix. Then using the concept of window and viewport, see, maximum x value of viewport minus maximum minimum x value of viewport gives you the width of the viewport. So width of the viewport by width of the height will give you the sx value. Then with height of the viewport by height of the window will give you the sy value. And using the concept of sy and sx value, you need to form this matrix, the scaling matrix. Then again, using the concept of lower left corner of your viewport, you need to formulate this matrix, that is the translation matrix. And when you will multiply these three matrices together, you will get the final answer, that is the viewing transformation matrix coordinates or matrix value. Okay. Is this answer clear to you? Yes or no? Is this sum or the way it is solved, is it clear to you? Yes or no?
Yes, ma'am.
Okay, 1 minute. Okay, fine. So this was one example of sum which I wanted to show you, because yesterday we were talking theoretically. So mathematically how it is done. Okay. Next topic is clipping. Fine. Next we will start the topic clipping. So as we were discussing yesterday, clipping is what? That suppose there are few portions of a picture or an image. Those portions, either those portions may be inside or outside. Suppose I have a window. My window is this. Here it is this, or here it is this, and here it is mountains, like this. Either I want to clip these things, or it may happen that inside my window also I want to clip this sun and I want to only portray the tree. So this all may happen. So any procedure that will identify the portions of a picture that are either inside or outside of a specified region, the procedure or using the algorithms which helps us to identify the portions, because first we need to identify the portions, right, which we want to clip. Then we can clip. So the algorithms which helps us in doing or in doing these things, those algorithms are known as clipping algorithms, and the entire procedure is known as clipping. And the region against which an object is to be clipped is known as our clip window. So procedure is known as clipping. The algorithms using which we clip is known as clipping algorithms, and the window against which we perform our clipping is known as our clip window. Okay. So the several type of concepts are there. There is point clipping, line clipping, curve clipping, polygon clipping, text clipping. Lot of clipping concepts are there. So we will be emphasizing on the line clipping and polygon clipping concepts. Okay. We will study a few algorithms for line clipping. Then we will study a few algorithms to how to clip a polygon. This is the thing. Now, what happens is, if I talk about line clipping concept, the basic concept, lines that will do not intersect our clipping window. Suppose I have a window like this. This can be one line, this can be one line, this can be one line, right? So the lines that do not intersect, this is our clipping window. Top boundary, bottom boundary, left boundary, right boundary, right? So the lines which will not intersect our clipping window can be either completely inside our window or it can be completely outside our window, right? So several segments of lines are there. One concept of line is totally visible line. That means that both the endpoints of the line segments, they lie within the window. This is one example of visible line segment. Another is non-visible line. That means both the endpoints of our line will lie outside our window. This is the example of that line segment. Another is the partially visible line. Partially visible means what? That part of it lies within the window. That means for this section, this part of the line falls within our window, but this part and this part is outside. So three categories of line segments can be there. One can be the line is totally visible, that we will include. Another is line is totally non-visible, that we won't include. Another is line is partially visible. Now, in case where the lines are partially visible, there we will apply the clipping algorithms, because when a line will intersect with our window, that means they are clipping against our window, then we find that what is the portion that has been clipped inside our window. This is the portion where we will apply the clipping algorithms to find how much portion of the entire line falls into our window. In order to find the coordinates, we need to apply the clipping algorithms. Okay. So, in the clipping concept starts, and inside under the clipping concepts, we will study the line clipping and the polygon clipping concept. So this was, first we will study the line clipping concepts, we will finish that, then we will study the polygon clipping concept. Okay. Now inside line clipping concept, three categories of line clipping procedures are there. Okay. So this was the first basic part which I discussed. Rest part we will be discussing in the next class. So this was all for today's class. I will just take the attendance and I will stop today's class. If you have any doubts in understanding, you may ask me. Okay. Abhijit, Akash, Akash Chandra, Amit, Amar, Aniket, Ankit, Jaiprakash, Keshav, Manish.
Yes, ma'am.
Keshav, Manish, Muskan,
Present, ma'am.
Palak, Rahul, Ravi,
Yes, ma'am.
Ritik, Riya, Sachin, Sandeep,
Yes, ma'am.
Sandeep, Satish, Shivam, Sumit,
Yes, ma'am.
Sumit, Shubhadeep, Abhishek, Aditya,
Yes, ma'am.
Anamika, Apeksha, Ashutosh.
Yes, ma'am.
Apeksha. Ashutosh, Babita, Chanchal.
Present, ma'am.
कौन बबीता?
Yes, ma'am.
अच्छा. चंचल, चांदनी, हेप्सिबा,
Yes, ma'am.
हेप्सिबा, हेप्सिबा, काजल.
Yes,
निधि.
ma'am.
कौन?
Ma'am Kajal.
ओके. निधि, पल्लवी, पूजा.
Yes, ma'am.
पूजा,
Pallavi.
पल्लवी. प्रीति, प्रीति वर्मा, प्रीति सिंह.
Yes, ma'am.
ओके. प्रीति वर्मा, पूजा प्रांतिका.
Yes, ma'am.
Yes, ma'am.
अच्छा. प्रीति वर्मा इज देयर.
Yes, ma'am.
ओके. राहिल, रंजीत, रोशन, रेहान, ऋतिक, संजय,
Yes, ma'am.
सावित्री, सियारा.
Yes, ma'am.
सावित्री,
Yes,
सियारा.
present, ma'am.
ओके.
Present, ma'am.
तमन्ना,
Yes, ma'am.
तमन्ना. तानिया.
Present, ma'am.
ओके. Okay, fine. So thank you for attending the class.
Thank you, ma'am.